electrical circuit analysis or circuit theory subject. Anna University syllabus, Unit 1st and DOT syllabus, Unit 3. In this video, we see nodal voltage analysis topic, that is DC circuit. We will see in this video Kirchhoff's current law and Ohm's law and matrix formulation is used in this circuit. Matrix determine value, matrix multiplication and matrix inverse value. That is very important. The calculations knowledge is very important. And Kirchhoff's current law says the current entering the algebraic sum of the current entering at any node is equal to the current away from that same node. What is Kirchhoff's current law say? V is IR. R is change in terms of conductance. We obtain I is V divided by R. So I is Vg. From Ohm's law, we obtain I is Vg. Put nodes. That is very important. That is nodal analysis, voltage analysis method. Man Engineering welcomes you all. Nodal elements points are very important. Small v1, small v2, v3, small v4, v5 are voltage across the conductance. That is the important point. Small v1. Nodal analysis method, nodal voltage analysis method, DC circuit shown in figure, that is consists of I1, I2 current supply and G1, G2, G3, G5 are conductance in most. Two or more elements meeting point is called node. So put node 1, 2, 3, 4 is reference node. And put nodal voltages capital V1, V2, V3. That is very important. Small voltages small v1, small v2, small v3, small v4, v5. That is voltage across the conductors G1, G2, G3, G4, G5. That is shown in circuits, assumed circuits. That is put in the circuits very important in this calculations method. Applying KCL at node 1. I1 is V divided by R, Vg, that is Ohm's law. Node 1 supply is I1 is equal to Vg formula apply. V1, small v1, G1 plus, capital V1, G1 plus bracket of capital V1 minus capital V2 into G2 at node 2. G2, G3, G4 elements are meeting. So G3 across the voltage is V2, G3 plus G4 across the voltage is V2 minus V3. G2 across the voltage is V2 minus V1. So we form second equation V2 G3 plus V2 minus V3 G4 plus V2 minus V1 G2 is 0. At node 3 meeting elements are G4, G5 and I2. So I2 value is Vg. I2 is V3 G5 plus V3 minus V2 G4. G4 across the voltage is V3 minus V2. V3 and V2 is opposite direction. So put minus V2. G5 across the voltage is V3. That is all the capital V3. Three equations. V is capital V3. From these three equations form matrix format. and small V1, V2, V3, V4, V5 is obtained from circuits. Small v1 is capital V1, small v2 V1 minus V2, small v3 V2, small v4 V2 minus V3, small v5 capital V3. That is obtained from circuit. Determine the voltage across the each conductance of the following circuits. That is questions. Nodal analysis method. 6 ampere source and 4 ampere source. That is 6 ampere is rising direction. Left side put plus sign. Left side put minus sign. Minus to plus. Right side put plus sign. 4 ampere is downward direction. Left side put plus sign. Right side put minus sign. Small v1 is voltage across the conductor. Small v1, v2, v3. Node 1 contain 4 plus 2 meeting element, node 1. And node 2 meeting element is 2 plus 5. 2 and 5 as meeting elements. And 4 ampere source. Node 1, 4 and 2 ohm resistance and meeting element is 6 ampere source. Kindly noted, node 1 meeting element is 6 ampere source, 4 ohm, 2 ohm. In this way we form matrix. And node 2 meeting element is 4 ampere, 5 ohm and 2 ohm. That is important. In this, from this way, node 1 4 plus 2, node 2 2 plus 5, common element minus 2, V1, capital V1, V2, sources 6 minus 4. Form matrix format, find determine value cofactor matrix and multiplication. From this value I have done V1, V2 values. From V1, V2 values find out small V1, V2, V3. That is small V1, V2, V3 formula is obtained from circuit. Small V1 depends on the voltages capital V1. So capital V1. Small V2 depends on the voltages capital V1 and V2. So V1 and V2 is opposite direction. So small V2 is V1 minus V2. Small V3 is depends on the voltage only capital V2. So put V2. That is important. Nodal analysis in terms of resistance. Resistance shown in figure that consists of VA, voltage sources VA and VB, resistance RA, RB, RC, RD, RE and put to node points 1, 2 and reference point V1, V2, that is nodal voltages. We apply the formula meeting at node 1 point RA, RB, RC and VA. So 1 divided by RA plus 1 divided by RB plus 1 divided by RC. VA divided by RA in voltage matrix. That is minus to plus, minus left side, plus sign right side. And second node meeting element is RC, RD, RE. 1 divided by RC plus 1 divided by RD plus 1 divided by RE into V2. That is depends on the voltage V2. From this way we form matrix format. Common element is RC, 1 minus 1 divided by RC minus 1 divided by RC. In this way form matrix format. VA depends on the RA resistance, so VA divided by RA. VB depends on the RE resistance, so VB divided by RE. In this way we calculate the problem. Find the voltage at node 1 and 2. The formula is above discussion formula is used in this format. 1 divided by RA divided by 1 divided by RA divided plus 1 divided by RC. 1 divided by RC plus 1 divided by RD plus 1 divided by RE. VA divided by RA 10 divided by 4. VB divided by RA 21 divided by 5. The same circuit model. So same formula is used in this. We form matrix format V1, V2. Circuit format is before explained. From this Matrix format we operate determine value cofactor value and adjacent A value. Only we find out V1, V2 values. Node meeting element is very important with 4 ohm, 3 ohm and 10 ohm, 10 volts. First node is meeting. Second node meeting elements are 10 ohm, 2 ohm, 5 ohm and 20 volt supply. In this way, we calculate the node voltages. V1, V2 matrix, capital V1, V2 are node voltages. We find out 0.683 minus 0.1 minus 0.1, 0.8. Inverse matrix are 2.55. Finally, A determined value 0.5364. Same question model given. Meet node 1 and node 2 and reference node. Node 1 meeting element is important and node 2 meeting element is important. G into V. Vg is I. That formula is used. I is 10 divided by 4. I is 25 divided by 5. Ohm's law and Kirchhoff's current law is used in this method, and matrix formulations, matrix calculations used. Inverse matrix, determinant value matrix and multiplication matrix are used in this method, nodal voltage method. For cofactor matrix, we obtain V1, V2, capital V1, V2, we obtain Nly. V1, V2 is 1 divided by 0.5364 into 2.53.65 matrix is equal to 2.5 divided by 0.5364, 3.65 divided by 0.5364 matrix. We obtain. Nly we obtain V1, V2 matrix value 4.6607, 6.8046. That is nodal voltage V1, V2 values in this circuit. Model circuits are before explained in this video. That is nodal voltage method, unionized syllabus and dot syllabus. Kindly use this method for DC circuits. Simple node only one junction. Principal node is more than one node, that is hint. In this method, Kirchhoff's current law and Ohm's law change into conductance format. I is Vg and mathematical function, matrix mathematical functions, inverse matrix, determinant value matrix, multiplication matrix, that is important. Node points are noted important. 1, 2, 3 and reference node. No meeting elements and that node is important. Eating node elements are calculated at that node. Man engineering, thank you. First page of nodal analysis circuits, small v1 and small v2 and small v3, v4, v5 is voltage across the conductors g1, g2, g3, g4, g5. That is, the small v1 is dependent on the nodal voltage capital V1. So put V1. Small v2 is dependent on the nodal voltage V1 and V2. So V1 minus V2, that is opposite direction, so put minus V2. Small V3 is depends on the nodal voltage V2, so small V3 is capital V2. Small V4 is depends on the nodal voltages V2 and V3, that is opposite direction, so put minus V3, V2 minus V3, small V4. Small V5 is depends on the nodal voltages capital V3, so put small v5 is capital V3. That is first page of explanations. Kindly note the first page of explanation in nodal analysis, bending of explanations. Kindly noted. Thank you. And thank you.